Number 71. A girl of weight 500 newtons runs up a flight of stairs in 10 seconds. So she runs up, okay, in 10 seconds. She covered this distance in 10 seconds. The vertical height of the stair is 5 meters. So this height is 5 meters. What is the average power developed by this girl? So power is actually right now it's a potential energy case. So we can see potential energy over time. So we know that potential energy is weight into height over time. Weight is 500 newtons, height is 5 meters, and time taken is 10 seconds. So it would be 250. So weight is 250 newtons. Okay. Oh, sorry. This is power. Power is 250 watt. Sorry, my bad. Number 72. When a nucleus of uranium 235 absorbs a neutron, yes, the 235 neutron will uranium nucleus would be stable, unstable, and nuclear fission occurs. Okay. In a typical radiation, the mass decreased by this amount. Okay. Given that the speed of light is this one, approximately how much energy is released? Okay, the mass decreased means this mass, this mass is converted into energy or released in the form of radiation or energy form. So we can use again, we can use Einstein equation. We know mass. Mass is 3 into 10 to the power minus 28. And C square is 3 into 10 to the power 8. And there is a whole square. So it would become 3 times 9 times 10 to the power minus 28 into 10 to the power 16. So it would become 27 times 10 to the power minus 12, and it would become 2.7 into 10 to the power minus 11. So 2.7 it can be approximately mentioned as 3. So our possible answer is 3 into 10 to the power minus 11. Minus 11. This is the answer. Next is number 73. In 73, a car is driven along a level road. The total energy input from the petrol is, this is input energy. Input energy is 60 joules and the car weighs 745 joules. It means this 60 kilojoule energy was given to this car, and 45 out of which is totally wasted. So we are left with 60 minus 45. We are left with only 15 kilojoules energy, which is our useful energy. So we know that energy, in case of efficiency, useful output energy over input energy multiplied with 100%. So total output energy is 15, input is 60. So 0 is cancelled with 0. So 10 times 15 is 150% divided by 6, and it would become 25%. So 25% of the energy is our useful energy. Yeah, is the efficiency, sorry. 25% is our efficiency. 25% is the efficiency of the car. 74. Hydroelectric, tidal, and fossil fuels are three sources of, like, hydroelectric. Tidal, hydroelectric means then like related with dams. Tidal is seas. Fossil fuels like coal and petrol, natural gas, these things. Which of these are renewable energy sources? So hydroelectric is a renewable energy resource. Tidal waves are renewable energy resource. And fossil fuel is not a renewable energy resource. So our answer is this one. Number 75. The diagram shows the energy transfer through a machine. Input energy is given to machine and useful output and some wasted energy. The machine is 50%. So it is actually a kind of repeated question in which like the 50% is useful and 50% is wasted. It means both wasted amount and this is 50%. This is also 50%. So both are 50-50, means both are equal. And we know that in previous question, our answer was this one. Wasted energy and useful output energies are equal. Okay. Number 76 is when a 300 Newton force is applied, okay, on a box having weight of 600 Newtons, the box moves 3 meters horizontally in 20 seconds. So this is the distance traveled by this box. The box is lying here. It has a weight of 600 Newtons and you are applying 300 Newtons force. So 600 Newton force would be applied by the earth in upward direction. That would be normal force. So normal force and weight are balanced because it is actually in contact with earth's surface. So when it would be in contact, so contact forces are applicable. So 300 Newton will act in this direction. And it travels a 3-meter distance, this one. What is the average power? Right now, it is actually a kind of force, distance. So it's a kind of work-like situation. So power would be equal to work over time, work done per unit time. So work done is force into displacement over time. So force is 300 newtons, which is applied force. Displacement is 3 and time taken is 20 seconds. So 90 divided by 2, it would be 45. So 40 power would be 45 watt. So this is our correct option. Which energy changes take place when a paddling cycle, when a paddling cyclist uses a generator dynamo to light his bicycle lamp? Which energy changes take place when a paddling cycle? When a person is paddling, it means some kind of kinetic energy. Generator means generator will actually convert that kinetic energy. Okay. Paddling results kinetic energy, and generator will generate electrical energy, and that electrical energy is converted into light energy. So we have three stages. But before that, when a cyclist is paddling, actually the person contains chemical energy in the form of food which is absorbed by the cyclist. So initially we will have chemical energy is converted into chemical energy. So first chemical energy is converted into paddling means kinetic energy. Kinetic energy is then converted into, is given to like generator will convert that kinetic energy into electrical energy. That electrical energy will result the lightning process. So initially chemical energy, so chemical energy is here. Oh no. So I think chemical to kinetic, kinetic to electrical, electrical to light. That's the correct option. So light is like electrical energy is the ending result. So that's why this option is incorrect. Now look, suppose we just considered like due to kinetic energy, our kinetic energy, chemical, light, and then electrical. Like light is not the source of electrical energy. So there is a confusion. There is a wrong sequence. So that's why it's wrong here. So overall wrong. Light, then electrical. Like we cannot convert the light into a. It's a reverse order. Light is converted into electrical to kinetic, like how? It makes no sense. Okay. A boy who weighs 50 newton, runs up a flight of stairs 6.5 meter high, and time taken is 7 seconds. Okay, weight, height, and time. So it's very simple. We know that it's a potential energy case. So power is, and potential energy is weight into height over time. So weight is 50 newtons, height is 6.5, and time is 7. So we can see like there is a yes, this option is quite similar to our results. So we can mark it like this. Okay. A student who weighs 500 Newton weight climbs up a flight of 6 meters high in 5 seconds. So again, we have similar type of things. Weight is given, height is given, time is given. So weight into height divided by time, 500 into 10 divided by 5, 500 into 10. So there is something missing. Okay, something is missing here, so we can write it by ourselves. Okay, 500 weight. Again, potential energy power formula is, so weight is 500, height is 10, and time taken is 5. So now you can see the B option is similar. Okay. Now number 80. A rock of mass 20 kg is traveling in space at a speed of 6 meter per second. Okay, now mass is given, speed is given. What is the kinetic energy? We know the kinetic energy is half mv squared. Half is half. Mass is 20 and speed is 6 square. So it would be 10. So 360 joule is the answer.